Hello and welcome to my tutorial on conduction. Today's learning objective is to know how heat moves by conduction. And hopefully by the end of this tutorial, you should be able to state which materials are conductors and which are insulators. And you should also be able to explain why some materials make better thermal conductors than others. So what is conduction? Well, conduction is a process by which vibrating particles transfer energy to neighbouring particles. So my diagram here is representing a solid, and the circles represent the particles of that solid, and the arrows are to show that those particles are all vibrating. However, you can see the longer arrows at the hotter end of the solid show the particles are vibrating much more. Now, when those particles vibrate, they collide with neighbouring particles. And it's these collisions that cause energy to be transferred between the particles' kinetic energy stores. And it's this that causes energy to be transferred from the hot end of the solid to the cooler end of the solid. Now, if we were to look at this process in more detail, we would see that when an object is heated, energy is transferred to the thermal energy store of that object. And this energy is shared across the kinetic energy stores of that object's particles. Now you can see that this solid is being heated at one end. And because it's been heated at one end, more energy will be transferred to the kinetic energy stores of the particles in the part being heated. And as I said previously, these particles will then vibrate more and collide with each other. And it's these collisions that cause energy to be transferred between the particles' kinetic energy stores. And this process will continue throughout the object until the energy is spread evenly across the object. Eventually, the energy is transferred to the thermal energy store of the surroundings or anything else that might touch that object. So what I would like you to do, please pause this video and take some time to read through those bullet points a couple of times yourself. Familiarise yourself with how conduction works. And then when you're happy, press play. Right, okay, to fully appreciate how conduction works, it's important that you understand the three states of matter. So hopefully you should all be able to identify the state from the following diagrams. So what would this diagram be? What would this diagram be? And how would you label this diagram? So hopefully you would have said that the first diagram represents the particles in a solid. The second diagram represents the particles in a liquid. And the final diagram represents the particles in a gas. Now, how would you describe the arrangement of the particles for each state? How did you know that was a solid? How did you know that was a liquid? How would you know that was a gas? When you describe the arrangement, you're literally saying what you see there. So have a go at describing the arrangement of the particles for each state yourself. Pause the video when you do this. And when you're happy with your answers, please press play. Right, okay. So the first diagram shows a solid. And you can see the particles are packed in a regular arrangement with very small spaces between those particles. Now in a liquid, these particles are more loosely arranged They're still close together and they've still got small spaces between them. And finally, in a gas, there is no particular arrangement of those particles. And there will be very big spaces between those particles as well. So, could you list the three states in order of thermal conductivity? So which one is the best conductor and which one is the worst conductor? I'd like you to start with the highest. Now, in order to list the states in order of thermal conductivity, you need to have an understanding of how the arrangement of the particles in each state facilitate how the particles will collide to pass on that energy. Think about how those particles are arranged. And then what I would like you to do is try and explain your answer. So hopefully you'd say the solids are the best thermal conductors. They've got the highest thermal conductivity, followed by liquids. And then finally, gases are the worst conductors of heat. What I would like you to do is I would like you to pause the video and take your time to explain why solids make the best conductors of heat and why liquids and gases are lower in terms of thermal conductivity, gas being the worst. Remember, when you're giving your answer, that conduction is a process by which vibrating particles transfer energy to neighbouring particles. Right, hopefully you could provide an answer a bit like this one. So, why are solids the best conductors of heat? Well, the particles in a solid are packed more closely together and they are in fixed positions. And it's this close proximity that enables them to collide more easily when they vibrate. Now, particles in liquids and gases, they're much more free to move around. So their particles will collide less frequently, which is why they usually transfer energy by convection instead of conduction. Now, gas particles are really spaced out, which means that they are the least likely to collide. And that's what makes them the worst conductors of heat. Right, you could be asked to categorise certain objects as good and bad conductors of heat. What I would like you to do is I would like you to pause the video and sketch a table. Have one heading of a column, good conductors or good thermal conductors, and the second heading, poor thermal conductors. And then what I would like you to do is categorise the following objects as good and bad conductors of heat. Pause your video whilst you're doing that and press play when you're happy with your answer. Right, hopefully you would have had the following answer. Hopefully that you said brass, copper, aluminium and silver are good thermal conductors, whilst air, cotton wool, cork, glass and wood are bad thermal conductors. Now you can see over here, all of these, okay, are metals. In fact, brass is an alloy, which is a mixture of metals. And metals have high thermal conductivity. So what we're going to be looking at next is why metals have high thermal conductivity. Why are metals such good thermal conductors? So thermal conductivity, what do we mean by thermal conductivity? What all thermal conductivity is it's a measure of how quickly energy is transferred through a material. And materials that have a high thermal conductivity transfer energy much more quickly between their particles. So the higher the material's thermal conductivity, the faster that energy will be transferred through it by conduction. And materials with a high thermal conductivity are known as thermal conductors, and those with a low thermal conductivity are called thermal insulators. So, which would be the more sensible thing to do? A or B? You can see in diagram A, the person is stirring that sauce with a metal spoon. And in diagram B, the same person is stirring the sauce with a wooden spoon. Pause your video whilst you provide an answer. When you're happy with your answer, press play. Right, hopefully you said that B was more sensible, to stir your sauce with a wooden spoon. And this is because wood is a thermal insulator. It has low thermal conductivity. You will not burn your hand because that heat energy, that energy, will not be transferred very quickly through that wood. Now, if you stirred your sauce with a metal spoon, which has a high thermal conductivity, the heat transfer through that spoon will be very rapid, and that will result in your hand getting burned. So why do metals have high thermal conductivity? Well, metals are good conductors of thermal energy because their delocalized electrons transfer energy. That's a really important statement to revise. Metals are good conductors of thermal energy because their delocalized electrons transfer energy. Please try and commit that to memory. What does it actually mean though? Well, in a piece of metal, the electrons can leave their atom's outer shell, and then they move about in the metal as free electrons. And we call these free electrons delocalized electrons. So you can see that in this diagram that the electrons have left the outer shell of those metal atoms. And what you've got left behind are positively charged metal ions. They're positively charged because they've lost electrons from their outer shell. And these ions are packed really close together and they're vibrating continually. And the hotter the metal, the more kinetic energy these vibrations have. And this kinetic energy is going to be transferred from the hot parts of the metal to the cooler parts of the metal by those free or delocalized electrons as well. So it's not just about the particles colliding with each other. These free electrons from the outer shell can also move through the metal and vibrate with the ions, and when they will collide with the ions, I should say, and they can transfer the kinetic energy. So why are metals good conductors of thermal energy? Because they have these delocalized electrons to transfer the energy as well. So why are pots and pans usually made from copper or stainless steel? Well, the reason is these metals have high thermal conductivity. We've just talked about the fact that metals have delocalized electrons and that these electrons can move through the metal and transfer the kinetic energy through colliding with the metal ions. So this means that they will actually transfer energy very quickly. Now this is ideal for cooking because the energy is going to be transferred to the food much more quickly. And that makes the cooking quicker. Why are the handles? What are they made from? And why? Well, the pan handles are usually made of a thermal insulator. And that's so the handle stays cool. Because what do we know about a thermal insulator? Well, we know that heat travels through the insulator really slowly. And that means that you don't end up burning your hand when you touch it. Now, that handle might be made from plastic or wood that are both poor conductors, okay, of heat. They have low thermal conductivity. So in class, your teacher might have done a practical similar to this. Now, sometimes Vaseline is used to adhere a drawing pin to metal rods, or alternatively, wax is used to secure the drawing pin. So this investigation can be used to investigate which metal is the best conductor of heat, so has the highest thermal conductivity. So your teacher might give you some long thin rods of different metals. For example, iron, brass, which we know is an alloy, a mixture of metals, copper, and aluminium. She might give you wax or Vaseline, drawing pins, and a Bunsen burner. Now this arrow here showing heat represents a Bunsen burner. What you would do to investigate the which metal is the best conductor, you would place the 4 metal rods on a tripod stand so that they are touching at one end. So you can see the 4 metal rods are touching at one end here. And what you would do is you would stick a drawing pin on the end of each rod using either Vaseline or wax. Now, if you're using wax, what I would suggest you do is you turn your rod over and then with a candle, just put a few drops, and it has to be uniform for each, but put a few drops of hot wax onto your metal rod at the end. And then immediately place your drawing pin on that hot wax. And then leave it for a minute. And what will happen is as the wax cools, it will adhere that drawing pin to that metal rod. So you use a Bunsen burner flame to heat one end of the rods, and that's where the rods meet. So it's at this end. It's not where you've just attached the drawing pins. And then using a stopwatch, you would record the time taken for the wax or Vaseline to melt and the drawing pin to drop off the metal rod. And the one that does this in the fastest time is going to be attached to the rod which has the highest thermal conductivity, i.e. is the best conductor. Because what would have happened for that wax to have melted or the Vaseline to have melted to release the drawing pin, that heat must have been transferred from this hot end of the rods to the cooler end. So what variables would you need to control? So if we look back at this diagram, you'd want to use the same amount of wax or the same amount of Vaseline to ensure that your results can be compared. Any variable would be something that could affect the time taking for the drawing pins to fall. If you use more wax, it would take longer to melt it. Similarly, the distance the rods are from the flame. So you would need to make sure that your rods were all the same distance from that hot flame of the Bunsen burner. The thickness of the metal. And as we said previously, the amount of wax used to secure the drawing pen. Now, some schools have a piece of equipment like this, which is an alternative to what I've just shown you on the earlier slide. And what you would actually do here is you would, your Bunsen burner would literally heat the center here of those 4 rods. And what would happen is you would attach, the same way you would attach a drawing pin with wax or Vaseline to the end of these rods. And then as the heat is transferred by conduction through the rods, the Vaseline or wax will melt and the drawing pin will fall. But this is similar equipment to what we've shown, but a lot of schools will use something very similar to this design. So how much have you understood from this tutorial? So we're going to have a little quiz now. So if you've got a pen and paper, okay, have it ready. So question 1, which statement correctly defines conduction? Is it A, it's a principle wherein heat is transmitted by currents in a fluid, i.e. a liquid or gas? B, it is a heat transfer mechanism in which a transition takes place through electromagnetic waves? Or is it C, it is a process by which vibrating particles transfer energy to neighbouring particles? So write down which statement correctly defines conduction. Is it A, B, or C? Right, hopefully you said C, which would be correct. Conduction is a process by which vibrating particles transfer energy to neighbouring particles. Right, question 2. Can you list the 3 states in order of thermal conductivity, starting with the highest? Does it go A, gas, liquid, solid, B, solid, liquid, gas, or C, liquid, gas, solid? Hopefully you said B, solid, liquid, then finally gas. Solid has the highest thermal conductivity. So question 3, which arrangement or statement correctly describes the arrangement of the particles in a solid? So is it A, do solids have no particular arrangement and very big spaces between the particles? Or do they B, have loosely arranged particles which are still close together, but there are smaller spaces between the particles? Or finally C, are the particles in a solid closely packed in a regular arrangement with very small spaces between the particles? Hopefully you said C. Solids have closely packed particles in a regular arrangement with very small spaces between the particles. So question 4, which of the following is a bad thermal conductor? Is it A, brass, B, aluminium, or C, glass? Hopefully you said C for that one. Brass and aluminium are good conductors of heat, or better than glass anyway. So put the following statements about conduction in the correct order. So I'd like you to pause your video for this one and take your time over it. You don't need to write out every sentence. You just need to write A, B, C, D, E, and F in the correct order. When you're happy with your answer, press play. Right, okay. Hopefully your answers were D, B, E, C, F, and then finally A. And just to recap, when an object's heated, energy is transferred to the thermal energy store of the object. This energy is then shared across the kinetic energy stores of the object's particles. And more energy is transferred to the kinetic energy stores of the particles in the part of the object that's being heated. These particles vibrate more and collide with each other. And it's these collisions that cause energy to be transferred between the particles' kinetic energy stores. And this process will continue throughout the solid until the energy is spread out evenly across that object. And then eventually it will be transferred to the thermal energy store of the surroundings, or again, anything else that might touch that object. Right, question 6. Why do metals have high thermal conductivity? Is it because A, metals are good conductors of thermal energy because their delocalized electrons transfer energy? Or is it B, metals are good conductors of thermal energy because their atoms vibrate more and collide with each other? Or is it C, metals are good conductors of thermal energy because their particles are loosely arranged, but still close together with small spaces between the particles? Right, your answer should have been A. Metals are the best conductors of heat because they have delocalized electrons that transfer the energy. So it's not just about the ions colliding and passing on energy. The delocalized electrons also transfer energy through collisions. So thank you for my tutorial, for going through my tutorial on conduction. If you have any further questions, please feel free to post them below in the comment section. And in my next tutorial, we're going to be looking at convection.